Yeah, you have to be like Jesus Christ. You know, when the one sheep is lost, you leave the rest go and get. Very well, Richard. I'm repeating. Channel include input output stream. And you can see the way it is the syntax for C++. You must have this particular sign. Uh, it's we normally call it is less than. Then you write the keyword input EO stream, and then you close with this. You will be able to actually get the concept in C++. Oh, so I want to repeat the entire statement so that you can get it. Channel include input, output stream. Uh, it is called a processor directive. This part called channel include is a directive. It's like I can tell you, before you come to class, make sure you have your laptop. Are we getting that? So this channel include is telling the compiler that before you compile this program, include another file called input output stream within this particular compilation context of the program. I don't want to use very technical terms. I want to say that when the program is being compiled, the compiler will get this particular statement, channel include EO stream, then it will know. There is a header file I am supposed to bring into this particular program before I continue compiling it. And it will assist me to know the meaning of the sum of the keyword that I'm going to use. And I want to be very precise by saying it will enable me know the meaning of the C out. When I get the C out and I get some statement after the C out keyword, I'll know this is something which is going to be displayed on the screen of a computer. So channel include is a directive. EO stream is another file that has a meaning of the keyword C out. If you don't include this and use the C out keyword in your program, the compiler will get confused and it will not know the meaning of C out and you will get an error. Hopefully, all of you have gotten that statement, and if not, then I'll continue repeating until you get. Richard, are you okay now? Somehow? And the rest, I wish Ahmed Gandu, because Sydney, Joseph, Ted T, Richard, yeah. Whether their microphone or their headphones are on. I hope they are getting me. Hopefully, they should confirm. Now, let me continue. The second statement is called using namespace standard. STD means standard. Using namespace standard. Now, this is a link associated with this header file that includes the header file, and the location you will find it within your area is called namespace standard. Hence, using namespace standard. So the question comes in, what is namespace standard? Namespace standard is actually the location where header files are stored. So one of the header files we are looking for at this particular time is EO stream. So the compiler will go to a place called namespace standard and get that particular header file. Otherwise, if we remove this statement, the compiler will get confused. It will be looking for input output stream, but it cannot get it because it does not know where to find it. So you must include a keyword called using namespace standard, and actually you are assisting the compiler to be able to get the header file and bring it to this particular program. So namespace standard is a location where header files are located or stored. And one of the header files you're looking for at the moment is input output stream. I hope it's clear to all of you. The meaning of namespace standard. Kindly, one of you or two to confirm so that I can proceed. using namespace standard. I hope it's clear to all of you. Kindly confirm to me, because I don't want to proceed if you have not understood the meaning of using namespace standard. Yes, Ted, I can see you are typing. Richard, again, you are typing. Okay. Yeah, is it clear? Using namespace standard, the meaning of that is a location where header files are found, and now we are looking for input-output stream header file, so we must go there. The compiler must go to that place. So I believe it's okay. I'm still waiting for your confirmation so that I can proceed. Okay, very well. At least I can see Natasha, and I believe by sampling the rest are okay. Then I can proceed. You have lost one programmer. You are, he has come back. Huh? That's good. Yeah, let's proceed. Then the next statement is called int main. And then we have an opening and a closing bracket, normally referred to as an argument. This, I said last time that C++ is a collection of functions. Now the question comes in, what do you mean by functions? Functions is a collection of statements that performs specific tasks within a program, and then they link together to accomplish the task of the entire program. When a program has several functions, there must be an order. Let's say, for example, I give you an analogy. At home, you have the father, the mother, the children. Sometimes, I don't know whether the mother is the one who takes charge or the father, so that the rest can obey. I don't know. Maybe we can agree nowadays. Ladies, if I say that it's the father, you will complain. The parents are the one that actually coordinates and controls the children. The same case applies to C++ program, that there must be a main function. The main function in this case must have a keyword main. And what's the meaning for main? The compiler will start executing. Executing means it will start doing the work of that program from the main function. So it will always be looking for the keyword main within the program, and it will start now compiling and doing the work of that program. And according to the C++ syntax, the main function normally is denoted with the keyword int space main opening and a closing bracket. Now somebody might ask, Malim, why int? Int stands for, okay, I'm sure we have been talking about variables, declarations, data types, and I believe that initially we were talking about this. We are trying to say that this program this particular main function can deal with numbers, but I don't want you to confuse that with variable declarations. This is the standard syntax of the main function. It has started with the keyword int space main with an opening and a closing bracket. But as time goes by, we are going to change this particular keyword and put a different one, like now called void. But I don't want to make you confused. First, let me just go step by step so that you don't get confused. So int main is always the beginning of the main function. The beginning of the main function. That's where the function starts from. I hope it's clear. Please let me know whether it's clear. One of you to confirm so that we can proceed. And Matthew is typing. Aha, that's clear. So again, I'm doing sampling. The gentleman in the house seems to be clear. A lady to confirm also. I hope I'm okay with names. You know, sometimes I might find that names might mean different. Russia typing. All right. I think it's clear. We can proceed. Don't shy, because if you don't die alone. If you have a problem, please just put it on here. We are all learning. We are all learners. Yes. Okay. I want to proceed. Now, there is this curly bracket. Is a curl. Curl is not a normal bracket, but it's a curly bracket. What does this mean? It means that the main function normally has what we call a body. And in the body, this is where you put all what the program or the function is going to do. And it must be opened. We must open the body of the main function. So what happens here, we use the opening curly bracket, and then we continue. Then after this, I have decided to put for you a comment, and this is called a line comment. We have a block comment, whereby you can block several, you can comment several lines, right? A statement here and another one here. There's that different format. But if you're writing a statement that you are communicating to a programmer, and you only want it to be in one line, you will use this do slashes, and then this backslashes, and then you write what exactly the meaning. So here we are describing the statement below this statement. Now here we are saying for loop execution, I want to maybe put it in an easier way. The loop starts here. Are we there? The loop starts here. Now today's class, we wanted to unfold the for loop, and this is an area I want you to be very attentive about. This is the area I want you to be attentive about, because if you don't understand this area now, that class will be like you do not be able to learn well. So we are going to look at the syntax. So what happens? You open the main body of the function, then immediately you start the loop. The loop will assist you to do the work quite a number of times. Like in our question, initially we said we want a program that is going to display numbers from 10, between 10 and 20. And then the program will stop. If it finds that there is 20, it will stop. So I want you to be attentive, because if you're not attentive, this is going to be very easy, but it's important also to understand that this requires logic to get. Now, the for loop is normally referred to as self-contained loop. The for loop is normally referred to as a self-contained loop. Now, Mwalimu, what do you mean by that? A self-contained loop is a loop that has what you call a starting point, an end point, and an increment statement. I want to repeat again. A loop is that one that has a self-contained loop as a starting point in it, an ending point, and an increment, and all of them are enclosed in brackets. All of them are enclosed in the bracket. That is just an expression. Now let me go to this particular loop. Now the syntax is as follows. For, you open a bracket, Then you declare a variable you are going to use for counting. And always we use numbers for counting. Hence the keyword int. I hope we are together. Then you initialize it to the lowest number or the starting point where it's going to start from. Like now, we have declared a variable called I as an integer, and we initialize it into 10, meaning that it will start counting from 10. Then we put a semicolon. This is the starting point. I hope it's clear. Are we there? Then after the semicolon, we give what we call the limit or the end point. That this loop will reach. Like now we are saying the I will continue until is not more than 20. As we are using the operator less than 20. So 20 is the limit. Are we there? 20 is what? The limit. Then we put a semicolon, a semicolon. Then we give the increment. I will be increased by 1. That's why we are saying I is equals to I plus 1. So from 10, if we increase 1, it will be 11. And again, if we increase 1, it will be to 12. So this is what you call a loop increment. So this loop has a starting point, which is what? 10, a limit which is 20, and an increment which is given as I equals to I plus 1. Then you close the bracket. Then again, you open the body of the loop. The body of the loop must also be opened. So here we open the function, and again we must open. So the loop will continue being the kind of work you want it to do till it reaches 20. So I want to repeat again. For I equals to 10, semicolon, and the I will not exceed 20, semicolon, increase I by 1. So this is the starting point. In fact, we declare a variable and we initialize it to the lowest number or the lowest value it's going to start from. Initialization is called the process of giving a variable a number. We have initialized it, we have given it 10, that's the lowest part. Then semicolon, then we give the limit. This is the limit. It will have to go to that I that starts from 10. Let it not reach past 20 or reach 20. If it reaches 20, the loop will stop. Then we have what we call the loop increment. Our loop is going to increase by 1. So I will be, like now in the case we are talking about, here initially is 10. We put, for example, 10 will be equal to 10 plus 1. So it will be 11. So the process will continue until our limit is reached. So, and then after that, we close the bracket and then we open the body of the loop and then we put what the loop is going to do for us. Like in this case, this is an example where we're using, we are saying that let us display those numbers that are being incremented. And we are using a concept here. But before I proceed on this line, let me ask a question to all of you. Have you understood that particular syntax of the loop? For I equals, for I open a bracket, int I, you declare a variable for counting, you give it the lowest value, semicolon, you give it the limit where it will reach, semicolon, you give us the increment. By what are you increasing? Are you increasing by 1 or 2? Like in this case, you're increasing by 1. I equals 1. So I equals to I plus 1, meaning that if it is 10, it will be 10 plus 1. And indeed, that shows we shall be increasing our counter by 1 as we proceed. So please, before I proceed to the next line of the body of the for loop, can I hear whether people have understood? This one now, I'm encouraging all of you to respond, whether you have understood on that particular side of the for syntax. whereby it's being initialized to the variable for counting. We are having the limit and then we are having the increment. Please, can I hear you respond through the chat? I will appreciate kindly. Yes, and I can see you are typing. Any question is encouraged, is welcome. Any question? Very well. And you can even talk, no problem. You'll be able to talk to me. I also appreciate. Good Richard, Doreen, okay. Aha, very good question, Teddy. I want to answer that. Yeah, and that's Grace, well, Mangi, okay. Purity, very fine. Teddy will wait. I will first see what everybody is getting, and then I'll answer your question. Veneza, Omolo, understood. Nazim, very well. Okay, increment part. I will in a moment. Let me see all of you whether you have understood. But next time you're going to see my face so that you don't think I'm a robot. Yeah, very good questions. I would like now to start answering the questions. Okay. All right. I would like to answer the questions. Yes, Pauline, Daniel, very well. I see Magara is typing. Instead of writing, can you write one? Okay, fine. I will ask to start answering the questions in a sequential manner. Starting from the first question, that was from the first question was from Teddy. What if you want to reduce? Very well, we are going to reduce. You can actually count backward. Like in this case, we can say in this program, we give, instead of giving the lower limit, we give the high limit here, we say 20. And then we come and we say until I is actually maybe greater than 1. Or we can also say is less than, let's say, we give the opposite actually. Then we come here and say I is equal I minus 1. So it will be counting backward. Instead of using a plus sign, you use a negative sign. We can actually reduce that particular. Now that one becomes what we call a backward looping, whereby it's counting from the highest point going downwards. So I don't know. Are you okay, Mr. Teddy and the rest? I believe that's clear. We can reduce that one, and we are going to do that practically. You can try to, if our compiler is going to work. Teddy, I believe it's fine. Eh? Please confirm. Good. Now I want to proceed to the next question. After Teddy, we had repeat the increment part by Narasha. Narasha, this increment, which is I equals to I plus 1, we normally say we give what we call a uniform addition. Like now we are saying we are counting from 1. We can say we want to count 1 to 5. So we'll count 1, go to 2, go to 3, go to 4, and then we reach 5. So we are increasing by 1. Then we say we want to count, maybe increasing by 2. So what will happen? If I'm in 1 and I want to increase by 2, then I'll add in 3. So I'll have 1, 3. If again I increase, I'll have 5. So increment, this is actually the standard way we could like our loop to count. Normally, by default, the loop counts by 1, adding 1 to itself, so that it can be able to count how many times you are going to perform the function. Like now, if I was adding marks for students who are 20, I will continue adding 1, add marks to the second, so the loop will go 1 by 1. So this one actually is the one that controls how our loop is going to be moving. It's going to count how many times the loop has gone. Then this is the one that will enable us to stop or continue. Like now, if let's say, for example, we have reached 19, I is 19, and then we say 19 is equals to 19 plus 1, that will be 20, then the loop will stop. I hope that is clear, Narasha. All right, it's clear to all of you. Very well. Decrement. Another question coming in. I don't know whether I'll answer that one now because I want to be very democratic. I am answering one by one. I don't want to be biased, but I'll come to that. That's all on Narisha. Digest that one. I'm coming to that one as we continue. Now, the next question is why are there two curly brackets? Oh, okay. Why are there brackets? Very well. Between 4 and when you open the for loop and close the syntax, whereby you are giving what we call is parameters. The keyword parameters is what defines, it's like hands. Like now you have hands. Yeah, a human being normally have hands. So our for loop also has what we call the parameters. The opening and the closing, I remember saying a for loop is self-contained. A for loop is self-contained. And indeed, the opening and the closing bracket contains all what it does. It contains the initial point, contains the limit, and contains the increment, and they must be enclosed for it to be a self-contained loop. So the brackets actually gives us what we call the parameters of that particular loop, the for loop, and it must be there, and there is a syntax that must be followed. I don't know whether I'm okay. Omolo, have you understood? Omolo, are you okay? Confirm, because I want to proceed so that we can do well, very well. Thank you. Thank you for your understanding. Now, the next one, the question was Magara. Instead of writing I plus 1, can we write 1 plus plus plus? I can see you are typing that and then you realize that you had forgotten and you came down here to write it. Now, let me say the reason why C++ has two signs normally is called an increment programming language, and it was actually improved from C. I want to be clear on this. In fact, when you use I equals I plus 1, we can actually substitute the entire statement here and say I plus plus, meaning that we are increasing I by 1. So if I write here, instead of writing I equals I plus 1, I remove the entire of this and write I equals I plus plus. Actually, you don't even have to put the equal sign. You simply say I plus plus. It means increase I by 1. The two addition signs actually increases I by 1. I hope it's clear, Maraga. Please confirm. And if you are decreasing, you say I minus minus, with two minuses. You decrease like that. Okay. I can see Magara is typing. And let's continue. Okay. I want to see that is satisfied. And when I refer to one, I am referring to all of you. So please, these questions are not specific to one person. They are also opening our insight to all of us. When one asks a question, I answer the question to the entire class. So kindly note that. Yes, Magara, it will give the same output. Thank you. It will get the same output. Hey, a very good question. I'll come to it, Martin, because I am very democratic. I'm very systematic and democratic. So just all the horses, I'm coming to that one. There's no problem. Now with Magara, I think we are fine. Let's proceed to the next question, which is after Magara. Doreen, Achien, kindly repeat the limit part for backward looping. Yes. Aha, this is. I wish I could have written a program in. Now in backward looping, what happens is that you start from the highest limit going downwards. Let's say we want to count from 20 to 10, correct? Yes, 20 to 10. I hope it's clear. 20. So what happens is very simple. You see now, I wish I could have gone out of this session and write a program again, but I know it will take a lot of unnecessary time, and then again we'll have distracted the entire class. So what happens is that we'll invest in this particular for area. We shall say for int I equals to 20. Now 20 is the highest limit. Then we are going to give the lowest limit where we are going to stop to. Then I, this is now what is going to mark the terminating part of the loop. And then we shall say 20. For I, it will repeat until I is actually less than, let's say greater than, we shall say for I is greater than, let's say 9 in this case. So that when it will reduce up to 9, it will stop. So we want this particular loop to be able to work from 20 to 10. So we shall say I is greater than 9. You can see this is now going to change. I hope you are seeing on the screen. So, and then we close our limit by the same comment. Then we have now to have a decrement. We shall say I equals to I minus 1. Are we there? I minus what? Minus 1. I believe already it's clear. Please confirm to me whether you have understood that. I'm waiting. Doreen. Okay, I see you're typing now. Good. Now, the same related question that comes after Doreen is Martin. Martin is saying, is there a difference between A plus plus and I plus plus? It will depend on the compiler you're using. Some of the compiler uses the other syntax and others use the other syntax. So it will depend on the version and the type of compiler in C++ you're using. There's no major difference on that. I believe, Martin, I'm clear on that, so that I can proceed. Martin, can you respond? Yeah, I can see you are typing. Very well. Thank you. So we want to proceed to the next line. So this curly bracket. So we had opened the main function. We also must open the body of the loop. It must be opened. Actually, we cannot. So you cannot have a loop that does not have a body. The loop also must have a body. So we also have a curly bracket for opening the body of the loop. Then we are going to put what this loop is going to display for us. So for us to see the output, like in this case, the loop is only going to display the numbers and the way they are being incremented from 10. So we have to format our output. Our output must be formatted. And how do you format it? Cout, we start with the cout keyword, meaning that display for us what is after the cout. And then we have what we call insertion operators. The two less than sign are called insertion operators. And these insertion operators normally means that display anything that is after this insertion point, which is in quotes or which is in the form of a variable. So we say cout, two insertion operators for cout, which are actually less than operators, two of them. Then we open a bracket and then we communicate. Like now we are simply saying the value of I, then we put the full colon and then we close. We are actually communicating in this scenario. We can change this statement to even our own mother tongue, depending on the person who is receiving this program. We can even change the statement and say the numbers that are being incremented are or increased are. So this one is not, I don't want to be static in your reasoning here. This is just communicating with the person. Then we have other two insertion operators. You can see we only have one cout, but we can use several operators or insertion operators that are associated with one keyword cout. Then cout I. I is the variable that is being displayed. And remember the variable I as a value. Like now, in this case, it's going to display 10, which is our first statement. Check if 10 is less than 20, and if it finds less than 20, it increases it by 1, and again, it comes back again and displays 11. Then go back with 11, check whether 11 is less than 20, and if finding is less than 20, it continues again, increase 11 by 1, get 12, display 12, and the loop will continue until we get this particular scenario whereby our statement becomes false, whereby I will be greater than 20 or is equals to 20, and that will be false, and that loop will stop. Then after displaying, we have another insertion point, which is actually associated with the first cout. All these three, this insertion point 1, insertion point 2, insertion point 3, all of them are actually associated with the keyword cout, which is at the beginning. And then we have a keyword called AND. This is AND with letter L at the end. Please note that. It's not 1, but L. And L is normally referred to as an escape sequence. An escape sequence. An escape sequence means we normally call it in a technical term a carriage return. And if I can be more specific and come to the layman language, it is actually like pressing the enter key on the keyboard when you are typing, for example. And when you press the enter key on the keyboard, the cursor will move on to the next line below. So the same case applies to this particular scenario, whereby after displaying 10, take the cursor downwards. So that 11 will be displayed and the cursor will be moved. So and L is used to move the cursor down one line after displaying. So and L is an escape sequence for moving the cursor downwards when displaying whatever output. Like now, these numbers will be displayed as 10, then the cursor goes downwards, 11, the cursor will go downwards like that, and those numbers will be displayed in a vertical way, not an horizontal way. So if you don't include this, if you don't include this one and the end L and you remove it, you will have the numbers, all of them in one line. They will be horizontal. So this one is used to move the cursor downwards so that the number can be displayed on a vertical dimension. Then after that, we close the body of the loop, and then we are done for that particular loop. So please again confirm. I believe this one was much easy. Whether you're okay, so that you can proceed again. Confirm, please. Yeah, Purity, I can see you want to talk. Huh? Yeah, you can type. Does it mean some of you have left? I understand the situation are in, maybe it's the bundles and all that, isn't it? Yes, Purity. Okay. Please, anybody with a question on that statement? Yeah. Evans? Oh, okay, I'll repeat. Let's see. Gitaka is also typing. Okay, I can see you are becoming English people of the Congress. You are seconding Evans. Good, Richard. I will repeat again. You know, learning a new language at this age is not easy. I wish you are all 1 year old will master the language. Anyway, let's proceed again. See out is a keyword for putting any statement to the computer screen. For see out to be effective, it must be linked with the insertion operators. The insertion operators for see out are two less than signs. Why I'm saying this is because we also have cin, which has its own different insertion operators. So the two must follow the cout keyword. Then after that, we have a statement for communication purposes. Like now, for you to communicate effectively the use of this program, you put the statement which is going to appear. Like as we are saying now, value of I. So the user will see they want the value of I. Actually, when the program runs, see out will not be seen. The insertion operator will not be seen. What will be seen is a value of I, which is currently, this is a string and is in double quotes. You can see that's the syntax. It must always be in double quotes. So even the double quotes will not be seen. This is what you are communicating. It must be in double quotes. And it will be communicating to whom are you communicating? You are communicating to a human being who is seeing the program and who is seeing the output. So if the program runs, it will receive value of I with full colon. Then again, we put other two insertion operators for outputting. So we are going to output the value of I as it is being incremented, and indeed we shall only use I here. So, and I said at the initial point, in our initialization in the loop, I was put to 10. So the first element to be displayed will be 10, and then the loop condition will be checked to see whether the value that has been displayed is less than 20, sorry. And if it's less than 20, that particular number I will be increased by 1. So it will be I, which is 10 is equals to 10 plus 1, we get 11. And again, it will come here, get displayed. And again, after displaying 11, it will be taken again into the conditioning checking. 11 is 11 less than 20, yes. So let's increase it again. So 11 will be increased by 11 is equal to 11 plus 1. It will be 12. It will be displayed again. 12 will be displayed and it will be taken back to the conditioning, check whether it's less than 20. Yes, 12 is less than 20. Increase it. Then it will be that 12 plus is equal to 12 plus 1. That will be 13. 13 again will be displayed. And after displaying, it's taken again to the conditioning checking. 13 is 13 less than 20. Yes. Let's increase the number. So it will be 13 is equals to 13 plus 1, we get 14. Again, 14 will be displayed. And after displaying, it will be taken back to the checking condition. Is 14 less than 20? Yes. Then we cannot continue. So we will continue increasing again. So it will be 14 is equals to 14 plus 1, we get 15. We display 15. And then we find, then again we go to the condition with 15. Is 15 less than 20? Yes. Increase it. 15 is equal to 15 plus 1, 16. We display it. Then again we go with 16 to the condition checking. Is 16 less than 20? Yes. We increase it. 16 is equal to 16 plus 1. We get 17. After getting 17, again we display it. And then we go back to the condition checking. Is 17 less than 20? Yes, increase 17. 17 will be equal to 17 plus 1, we get 18. And again we display 18, and then we go back again to the condition. Is 18 less than 20? Yes, increase it. 18 will be equal to 18 plus 1, we get 19. Then again we proceed. As we proceed again, we go come here, display 20, sorry, 19, and then is 19 less than? Is 19 less than? 20, yes, we'll increase it. 19 is equal to 19 plus 1, so we get 20. And then again, we continue displaying. After displaying, we come again, and then we check, is 20 less than 20? No. That is a false statement. We stop there. The loop will stop there. And then the program will stop after displaying the other elements. Then we said we also need to move the numbers downwards. So we are using another insertion operator to bring into the syntax of the C out an escape sequence. An escape sequence, in simple terms, it is a keyword or a note that is used to move the cursor downwards or vertically or horizontally. For us to move the cursor downwards, we normally use an L. And L means you move the cursor after displaying a number like 10, the cursor will move downwards, and then like that it will proceed for this until all the numbers are displayed. Then again, you must terminate the statement with a semicolon. And again, one thing I would like you to know that not all statements in C++ are terminated with semicolons. As you continue learning, you'll be able to know which areas. Like now, if we put a semicolon here on the for loop, it will be wrong. We are actually closing the loop before it is able to do its work. We are able to, I'm getting the echo from Purity. Maybe it's going to be okay. Now, once we have that, we have done our work, we close the loop. And after closing the loop, we have a keyword return 0. Please note this is not all, but return what? Return 0. It's a very important and a very, very effective statement in the C++ programs. And the purpose of this statement is like a communication to the system. And which system are we talking about? The operating system. Remember, the compiler is actually a programming language which runs under an operating system. Like now, when you open Windows is the operating system. First, you open Windows, and then you open the compiler C++. So the operating system is the one that manages the program, and when the program finishes doing its work, it has to communicate with the operating system that the program has successfully done its work. So this is a communication, and it's like a flag indicating that the program has run successfully. And finally, we close the bracket of the main function. And then that is the entire program for the for loop. I believe I'm clear. And if I'm clear, I really appreciate that. So this is an explanation. It's in your notes. You will be able to see when the loop is in your notes. And I believe that will be okay. Before we proceed, I don't think that I'll proceed from there because I need to be very cautious, because in programming you don't rush. You don't rush. First you leave the programmers to digest them, and then you can give it to. So for today, I believe I'll stop here. And I know we have challenges. We don't have computers to be able to program, but I think programming is done in our heads. Computers they're used as tools to confirm whether our programming is well. Once we understand that concept, the computer will come later. And when we get a computer and then code, we just confirm that things are okay. All right. Yeah. Magara is asking for the setup. The setup is very ready. In fact, if you can access internet, it's an open source program. It's about 50 MB. It's called CodeBlocks. But I still send it so that they can install. Although I'm also looking for the one that can run on Android operating systems, so that you can also try it. Otherwise, from my side, I'm having a feeling that every programmer has gotten something small back home today. So I would like to stop here, and I'm now welcoming any question before we went up the class, and then we proceed. Actually, I'm about to go for an exam that is supposed to be. We are also reflecting these exams online, so that you will allow me to proceed to the next level. I only have 2 minutes. Kindly let me have some questions and then we wind up the class. Kindly. Any comment, any gesture, any, yeah, I'm welcoming. Kindly for 1 minute. You have gone silent. Programmers are people known to be silent but programming. Eh? Silence means what? Understood? Class. Spirit, you can talk now. I can see your microphone is on. Oh, well done. Well done. Kosgei, Neka, well done. You don't be shy. If you are speaking, please, you continue, no problem. So can I say Irene, Joseph, Magarwa, Matthew, Naresha, Purity, Edwin, Ahmed, Nasrin, Omolo, Richard, Vanessa, Daniel, you are all fine. Thank you. I really appreciate your time. God bless you. Until we meet next time, take care and be safe. I promise you are going to see me soon. Thank you so much and God bless you. I'm ending the session. Keep on reading the notes until we meet next time. Bye bye for now. That's all about sio ni mwalimu kali kama that is smart. That is smart. Mwalimu anakupa yeah. Signal.
You are currently the only person in this conference. You are the only person in this conference.